Now we are going to conclude our derivation of functions with this last aspect of our topic by differentiating some standard functions given to us. So the first one we are going to be differentiating is what we call ln x. You have to find the y dx. You are given this function and you have to find the y dx. So solution. Now when I give you y to be equals to ln x, I'm going to do a quick explanation of what we call ln. This ln is established by a mathematician called Hyperion, and we call it Hyperion law. When you have ln, is the representation of log base e. This means that this is log s base e. Ln is also the inverse of exponential x. If you have ln s, is the inverse of exponential s. So there's a linkage between ln x and exponential s. That one is just by the way. But let's go back to what we have to do. If you have to find y prime, which is the y dx of this function, you have to differentiate, find the derivative of the function, then you write the function back. That's just the formula. It means that we are differentiating the function then x. Anytime you have an x, differentiate the function of x. In this case, this is going to be 1. Differentiate x is going to be 1, and you write the function back, which is x. That's just it. If you use the same approach to break this down, this is y is equals to ln 3s minus 5. Then that's going to be differentiate this one inside the bracket. Then that's 3, then you write the function back, this 3s minus 5. That's all. Now, this one is another function that we have to do. But this one is going to take us back to chain rule. It's one of the examples that we are supposed to have done in chain rule. This exponential 5x. If you are doing this is different from the exponential s that we explained initially. Exponential s does not have any coefficient. The coefficient there is just 1, as in the coefficient of x is 1. But in this case, we have 5 as its coefficient. So by differentiating this, you are to differentiate the whole function. This one has, and you differentiate the one at the top. It means that you are differentiating twice. You can use the approach of putting the one at the top as u and writing the whole function. You write it all over by saying y is equal to exponential u. You want to use that approach. But I'm using this, differentiating the whole function, and you differentiate the one that is depending on x. This is a function of a function rule. This whole function, y depends on this whole function, and this one at the top depends on x. So when you differentiate this whole function, based on the explanation we have, anytime you differentiate an exponential function, you get back the exponential function. It's still the same explanation. It's the same explanation. Then you differentiate this, and this is 5. Then this is 5 exponential 5x. So we'll conclude with this one. This one takes a lot of some kind of explanation. So let's just conclude with that. So let's deal with the derivative of this last function. Y is giving us exponential, a raised to the power x. This one is supposed to be having the base as exponential, but this one we are having another variable entirely, which is not an exponential. So how do we go about this particular derivative? So let's try to derive this function. I can write its derivative directly, but let's try and derive it. Now, so we can say let the base, which is a, let is equal to exponential k. Exponential was the basic, type of function that can look like this, type of expression that can look like this. But now we have it as a, so let's try to replace it. Take it back to the genesis. This is exponential, rewriting this, exponential ks, right? This is exponential ks. Then when you differentiate this, the y dx is going to be equals to k exponential ks, just like we just finished. We can't leave our answer like this because we have some following members there. K is a foreign member, exponential K is also a foreign member. So how do we go about removing K and exponential K so that we get the derivative with respect to in terms of A and X only? So in that case, when you look at A is equal to exponential K, can we get K from here? Yes, let's take ln on both sides. We have ln, we have K, ln E. Then don't forget I explained initially that this is a Nigerian law. This is like log E base E, and that's going to be 1. So we can say ln A equals to K, or we can say our K is equals to ln A. I've gotten my K now. Now I've gotten my K, then I also need my exponential K. My exponential K I'm giving to be A here. Then finally I can say my dy dx. My K is what? Ln A. My exponential K is A raised to the power x. So anytime you differentiate A raised to the power x is going to be what? A raised to the power x. It's like you are rewriting this thing back just like you do with the exponential. Then you are going to have ln. Instead of just differentiating the, you have ln of the base. You take ln of the base. And that's what we are going to cover as far as differentiation of functions is concerned, based on the scope of the West African Examination Council. If you want us to delve into a particular aspect of differentiation that we have not covered, it's a very wide topic, you can comment below and I will reach out to you. If you have some clarification you would like to, you like to get based on this particular topic or the one we have been doing so far, you can get to the description box and get in touch with us on our Facebook platform and our Twitter platform. Till we meet again, ideas rule the world.